Okay, so let's get started. I'm Taro Saito from Treasure Data. I'm going to introduce Wvlet, which is a new full-stack query language so that you can modernize your SQL-based query processing. So let's get started. No, actually, 2024 is 50th anniversary of SQL since it was born in 1974. And actually, SQL's early design choice actually paved us a way for its standardization and commercial adoption. So now we can use SQL for a wide variety of applications. So SQL mostly used for RDMS, but we can use it for analytical queries in Trino, Spark, etc. We also can use SQL for embedded database like SQLite, but its usage is spread to DuckDB, which also supports OLAP queries, accessing Parquet file, Iceberg tables, so which is really impressive spread of usage. And not only DBA, like database administrator who are expert of SQL, use case of SQL has grown to non-engineer. So many people are now trying to protect to SQL approach using LLM. So actually, yeah, the usage of SQL has spread really widely. Treasure Data is one of the biggest users of SQL and Trino. Treasure Data has been operating Trino since 2014, and actually this year is 10th anniversary of the service since we started Trino service. And we are now processing over 3 million queries every day, processing 400 trillion rows. Individual queries are issuing 3 more billions of S3 GET requests. We made aggressive optimization about our S3 GET access, so that number reaches from 10 billion requests per day since the last year. And the biggest news for us is in 2024, we completed the customer traffic migration from Presto 350, which was the last Trino version, right before rename from Presto to Trino. So currently, entire traffic are running on Trino. But that kind of migration was really challenging for us. So we detailed those methods in our DB test papers. So if you are interested, please take a look at the paper. The one thing I want to note here is we've seen a lot of SQL queries and challenges in managing SQL and also helping users. Or recently, you also need to help large language models to write better and efficient SQL queries. So we saw many problems in the SQL itself. One major thing in SQL is its syntactic order doesn't match the actual data flow. So even for experts with SQL, it's really difficult to debug what is wrong or how data is actually processed inside the SQL statements. So this is also criticized by Thomas Neumann, computer science, German-based computer scientist, inside the 2024 conference. And another problem in SQL is its standards is really minimum, covering only small areas of data processing. So it lacks essential software engineering feature like managing multiple queries. So SQL itself doesn't have any built-in support for reusing or generating queries. We don't have any entry point for optimizing multiple queries in order to implement incremental processing, or we can't implement data pipeline execution like dbt by using SQL itself. We also don't have any built-in debugging, testing capability for queries. We want those things for building reliable data pipelines. So what we did for addressing these challenges is building or modernizing SQL to incorporate the best practice of software engineering of the current days. But we also want to emphasize SQL itself has proven to be really successful and usable for many use cases, probably because its natural language-based syntax, its So it's been widely accepted for many types of users. So we just needed to redesign SQL just to be more intuitive and functional. So we created a new flow-style query language called Wvlet. So for weaving data. Then in Wvlet, all the queries start with from statement for representing intuitive data flow. Wvlet query are also functional so that we can reuse and compose more complex queries from query fragments. Wvlet itself doesn't stick to a single query engine. It can support multiple SQL engines like Trino, Hive, DuckDB, and so on. And you can try Wvlet on your web browser just by visiting wvlet.org website. No installation is required. If you visit the web page, you can immediately open this Wvlet playground on your web browser. In this screen, you can see Wvlet queries, and this query is compiled into this SQL statement. And this SQL statement is immediately executed and produces this query result. You can go to the site and play around multiple examples of Wvlet query in this playground. And here is a brief overview of the Wvlet's architecture. Wvlet basically receives query files whose extension is .wb. Wvlet compiler produces logical plans, execution plans, and SQL statements for the target databases. Logical plans of Wvlet are basically the same with Trino's logical plan, which are 3D representation of relational operators like scanning, filtering, projection. We can have multiple optimization entry points for those logical plans. Like if you can optimize your query just by rewriting some of the query to materials view or incrementalizing some part of the query, we can add those kind of optimization logic in this query rewrite framework. A unique point of Wvlet is Wvlet also creates execution plans, which is a sequence of steps for executing queries and other programs as well. So not only running SQL queries, we can run test code, or we can call external commands like calling external Python functions or calling other tools like mbag, which is another open source from treasure data for importing or exporting data from various data sources. So we can combine not only SQL, but also other programs as well in Wvlet. Here is a brief demo of how we can interactively explore the data by using Wvlet. Unique point of Wvlet is individual line is corresponding to a single relational operator. So as you write a query, you can explore the dataset or you can check the schema. Then you can, if you modify the query, you can immediately see what is happening, what kind of query will be shown. So experience of using Wvlet is really interactive and intuitive. So data is flowing from top to bottom. You can also save the query, then apply additional condition as shown in screen. Then you can add additional irrigation expression like this so that you can extend and modify query result. You can also customize query output by adding areas. Then you can reorder comments at least like this. Actually, Wvlet is not the first attempt to modernize SQL. Google SQL is another approach for streamlining SQL operators by introducing pipe syntax. Pipe syntax is this kind of characters. Then Google tries to reorder this query into flow style queries. Actually, this open source code is available in ZSQL, which is open source SQL parser used in Google's product like BigQuery or F1, which is Google's internal query interface for accessing various databases. We also can find many other full-stack languages like Precore, PRQL, and Microsoft Custom, Dry and Link are other types of attempt. So let's take a look at the relational operator defined in Wvlet. Before that, I want to make sure all the keywords in Wvlet must be lowercase letters. This is for maintaining the consistency of query syntax. If user use uppercase letters or lowercase letters in the query, the syntax looks really inconsistent. So we want to make sure we only allow lowercase letters as query keywords. And it's also reduced implementation effort for writing parser or tokenizer, highlighter, or formatter. But we introduced almost the same operator with SQL in Wvlet, like from statement, select, join, where, order by, limit. Those things are same in Wvlet. But aggregation in Wvlet is slightly different. So queries must use group by first. Then you can add aggregation operators like this, counting number of rows in the group or computing sum of quantity. You can save the cost of writing all the individual columns. You just need to specify grouping keys and aggregation expressions. Then you can, produce this kind of result. Basically, the flow of Wvlet is beginning from you can add multiple where statement, you can add more columns. Then finally you can apply some sorting or limitation. Wvlet also introduce common at a time operators for minimizing your typing effort. So you can add common, you need name, exclude some common, unnecessary comments, or you can also shift the order of comments in the table. So, but if you want to implement the same thing in the SQL, like shifting two columns, label, return flag to the left side, you need to enumerate all the columns in SQL. So it's really cumbersome to read, cumbersome to write, and also it's also difficult to understand the intention of the user in this SQL, what the user really want to do with this SQL. But if you write, if you explicitly write the intention, you just want to reorder the common position, then intention of the user is much more clearer in Wvlet. Wvlet introduced several changes to SQL to avoid common pitfall user fault, like Wvlet introduced concat operator, which is basically the same with union or in SQL. This is because most of SQL users wrongly use union, which includes duplicate elimination. And this is a really expensive but costly SQL operator because we need to store all the table data in memory. So, but most of the cases, user just can use union or just concatenating two tables. So we make sure by using concat operator, user don't apply expensive operation. But if you really want to remove duplicates, then dedup operator can be used instead. The utility operators like transforming only subset of comments or taking sample rows. Pivot is also introduced, which can be really easily implemented in Wvlet, which basically transform common values into individual comments. The ticket for adding pivot operator in Trino has been open since 2019 because it's really difficult to implement pivoting, dynamic pivoting in a single query path. But Wvlet can naturally run multiple SQL queries, so it's relatively easy to implement static or dynamic pivoting in Wvlet. We also have multiple shorthand notations for updates. Save as is a shorthand for drop table and then creating table. Until very recently, Trino didn't have create or replace table statement. So most of the treasure data users are using drop table, create table statement, and which became really frequent user pattern in treasure data. But user most of the cases, you just want to replace the table content, so having a save as statement is useful for yeah, making clear the intention of query statement. We also added append to statement, which is basically the same with insert into, but clarifies we only add new partition records to the table without any override, which will be useful for clarifying the intention when using versioned tables like Iceberg or Data Lake. The data is similar with SQL. Another improvement in Wvlet is using function chains connected with dot later. One of the problems in SQL is every function is global, meaning if you want to apply sum or average or counting, rounding, you always need to wrap input value with parentheses, but it's really cumbersome. You also need to move a lot of cursor in your text editor. So Wvlet supports dot chaining of functions. So you can write this SQL statement like this, quantity.average.rounding. Then you can, you don't need to move cursor row. You just need to type expression from left to right order, which really simplifies or effort for writing queries. And any query in Wvlet can be a sort of function in programming language. You can use queries for building your own data model. Then you can define Wvlet queries as a data model. This data model can be referenced in another query by, for example, you can add additional condition to filter unnecessary rows, or you can also compose multiple models to build more complex queries. And also, we can add parameter definition to the model so that you can parameterize your queries for using the same model for different purpose with slightly different conditions. Having tests is really essential for building reliable data model and data pipelines. Wvlet has a built-in test syntax which will be useful for verifying table query wizard schema and query wizards. For example, if you need to read this JSON data, you can add a test query like number of rows is 3, and the common schema should contain ID, name, and age comments. You can also use contain expression to simplify schema check. And Wvlet is actually tested by using Wvlet itself. So we have a bunch of spec queries. So if we add a new syntax to Wvlet, we also need to make sure we are going to test the behavior on expected result in the query itself. Wvlet already covers all the 22 TBCH query. We want to expand the coverage more for other type of benchmark like TBCDS. And we also introduced debugging capability to Wvlet so that you can inject the debug operator in the middle of your query. Then in this path, you can apply additional condition, or you can also save the intermediate query wizard to another table or another file. Then execute of Wvlet actually runs two parts of query. One is for regular query evaluation, another is for debugging query wizard. Then you can have a sneak peek of the intermediate query wizard, and you can actually test what kind of data is contained in the middle of the query. So this is really useful for debugging complex query without affecting production queries. Here is some brief internal of Wvlet. So Wvlet has multiple phases for compiling queries. First, it starts with parsing Wvlet text. It labels queries and symbols appear in query files, and resolving common schema for individual query stages, apply some rewrite optimization. Execution planner creates a plan for learning SQL. And finally, logical plan inside execution plans will be translated into SQL statement for target databases. And Wvlet uses a notion of compilation unit for holding the source query text and untyped or typed logical plans on execution plans and so on. If you are really interested in the details, you can use aspect testing library. And you can adjust the log level of individual components so that you can see the internal behavior of individual component. For example, this query is tokenized in those list of tokens internally. From these tokens, we will parser generate a logical plan, and typing is applied for reading the schema of input data and propagating common information to the upper stage. So the logical plan is basically similar to Trino's query plan. Then you can also see generated SQL queries and eventual query result as well. Here is the upcoming development plan of Wvlet. Wvlet is relatively new, so we are still working actively to make it more ready to use for production. And basically, we are having every milestone for every 3 months. Version will also match with the release year and milestone months. So we already completed basic design of Wvlet and created language parser, compiler, and SQL generator using DuckDB, Dialect, and Trino. We also have interactive command line editor, repo, evaluation like Trino, that is similar to Trino client. We also have homebrew installer to install Wvlet command locally. We also have web UI for learning Wvlet queries in your web browsers. In the upcoming release of Wvlet, we are planning to add more advanced model management so that you can generate model materialization plans like DBT. We also want to have GitHub integration so that you can read queries from GitHub repositories. We're also planning to implement compiler plugins so that adding more advanced query optimization like incremental processing, query fusion, which is already available in Wvlet Athena. We're also planning to add in language padding for Python, Rust, C++. If possible, we want to add secret to Wvlet converter so that to help user migrate their query from SQL to Wvlet at least. Then this is a summary of my presentation. So we've designed Wvlet with a new open source flow-style query language, which addresses real challenges in 50-year-old design of SQL, but we still want to retain the good parts of SQL, like its natural language, syntax, which is really easy to read. But we tweak the order of SQL so that syntax order will be similar to actual data flow. And we also enhanced SQL for reusable to make it more reusable and extensible. If you're interested, please visit wvlet.website. You can also see the source code of Wvlet and compiler in Wvlet GitHub repository. So that's all, and I want to pass to Wvlet.
Hey, Taro, that's amazing. That's a big project. So who's working on this? I looked a bit on the GitHub repository. There's only a handful of people, but like it must be adopted quite a bit already, right? Like you're testing this.
Currently, we are not using it in production yet, but maybe I started the project probably around March of this year. Then we are prototyping the idea of redesigning SQL and gradually getting confident this kind of flow syntax is actually useful. Once we created the interactive editor, you can immediately find how useful it is. So we are now trying to spread the effort to more. And some volunteer engineer is joining my project. Then we are seeing a lot of progress since the last couple of months. And we also get a lot of help from both users or GitHub Copilot, large language models, because writing compiler is getting really easy. For example, this is a really interesting example. If I type pass join for passing join statement in Wvlet, GitHub Copilot generates this volume of the code at least. So actually, GitHub Copilot is another author of the code. So I'm talking with GitHub Copilot every day to implement Wvlet, and we're making good progress. Because of the help from LLM.
That's quite amazing, isn't it? But very impressive effort. We also had questions about the separate pipeline SQL from Google. Eric, I had the question just before you ended up talking about that comparison. So are you in contact with these people on the Google side, or are they aware of your efforts, or is there?
I haven't contacted those people yet. So probably that's a nice idea to talk to them directly, because I just found this paper. I think this was published around June this year. So while I'm developing Wvlet, I found this paper is published. So actually, I learned a lot from this paper and incorporate some of their ideas into Wvlet as well. Having some collaboration would be really nice.
Yeah, no, it's always good to keep an eye on, and I admire you for paying attention to like very large database data articles and like reading this kind of like pretty dense, difficult topics, and like obviously you made a lot of progress already in your development. So very nice to see. Also wanted to mention, you were talking about some of the features that are like still missing in Trino, like pivot and stuff like that. It hasn't disappeared, and we're getting closer on these ideas to do some of those things. We're hoping, Martin mentioned this also in the keynote, we are hoping to do some of those language improvements, and we already have some table procedures now and in the Iceberg connector, for example, and we want to generify these and like improve some of those. So hopefully some of those utility and usability improvements will hopefully also land in Trino itself. That's really cool.
This is actually an example of running pivot query. This is a static pivot. You need to enumerate columns, but these column values will be expanded to individual fields.
We want to do that in Trino.
Actually, I implement this rewrite just in a day. So if you have a rewrite framework like this, it's easy to implement pivot, but it's really complicated to implement dynamic pivot just inside Trino's query optimizer in a single pass.
Well, we'll get there. The query optimizer is definitely something that will get some attention being modernized, just like the our dependencies and runtime and all the performance improvements. So there's always more help to be had and work to be done, which is exciting. But you're definitely making big inroads with Wvlet, so that's really cool. I think we are ready to head over to our next session in a minute or two, which will be the second last session, I think. And I'm hoping that everyone can stick around all to the end and join us with more questions as usual. And then we'll follow up on the conference with blog posts and videos and slides and all that stuff. And I'm sure people will also get access to your slide deck, and hopefully they will start your GitHub repository, check out the code base, and see it, try it out. And hopefully they try it out with Trino, right?
Trino integration is already working. So